Today I'm going to talk about topology of a network, and topology is just a very fancy word of saying the layout of a network. Now, when you think of layout of a network, you might think of your home network, where you might have a laptop, mobile phone, desktop, all put together around a router sending out a Wi-Fi signal. You might think of that as being in a physical layout of being circular or in a ring, and when we hear the term ring topology, you might get confused and think, hey, my home network's in a ring, isn't it? When we're thinking of topology, we're not thinking of the physical layout, we're thinking of how does the data move around my network. So let's go into a bit of detail and talk about a few of the different types of network layouts. First one I'm going to take a look at is the bus. Okay, so let's draw a diagram of our bus here. Here's our little stops for the bus to go to. So the way I like to remember how a bus network works is thinking of the bus stop. So you have various nodes there on your network. There's the start of our bus line. Let's not confuse it either with a bus inside a computer, which is the way you get data along a motherboard, that kind of a bus. This is a bus layout or a bus topology for a network. So here's our bus line here, and you can see that our line travels to every single point on the network, and I'm going to pick my data source here. Here's my source, and if I want to send some data to a receiver, what happens to my data? Let's send it down the line. So it goes down the line, checks here, are you my receiver? No. Goes along to the next stop on the bus line. Are you my receiver? No. Goes along to the end, the next point of the bus line, and there's my receiver. Let's pass out the data. So a few things that can happen in a bus line. One is, what if there's no receiver, if it's a dummy bit of data? You get some data flying around your network. So let's have a look at that scenario here. And keeps going down to the end, starts bouncing back again, and back again, and you've got lots of redundant data flying around your bus line, causing a lot of what's known as traffic or network noise. To avoid that, on a bus network, you normally have at the end of the line something called a terminator, not to be confused with an Arnold Schwarzenegger character, so that when my piece of data, which could be redundant, goes from the source and it doesn't find a receiver, it hits the terminator at the end of the line and it doesn't bounce back. Just finishes off there. Okay? Advantages of the bus network. Let's think about that. Well, one big advantage is cheap to set up. You got less cabling, don't you, than other types of networks. One single line there going out to each computer. Disadvantage. Okay, let's look at a break in the line here. Let's take out some of my bus line here. So if I put a break in my line here, boom. Okay, what will happen is, if there's a break in the central line, we can have big problems because if I'm sending data here, it can only get as far as this point here on my network. If it tries to go beyond this bus line, you're missing out 1-2 points on my line. So you're dependent very much on the central line. Another disadvantage is that with less cabling, there's more traffic on pressure on the cable that I use. Okay, it's like your superhighway on the road. If there's less lanes on the road, there's more pressure traffic-wise, to make a comparison there. Okay, again, we just have to be aware here that the ring topology, don't expect when you walk into a ring network to see it physically, everything laid out in a circle. Okay, so let's draw our nodes of the network first, our computers being our nodes here, if you like. There we go. I'll do 5 in mine, yeah. And I'm going to nominate a sender and a receiver. So on the network here, our data is going to get passed around in a ring or a circular fashion, and it's going to choose a direction in which to go. So we're going to have a network that passes around our data in a clockwise direction. Okay, so let's pick a sender and a receiver and track the data. There's my sender, there's my receiver. Okay, and let's track our data. So the sender gets a piece of data, and you're reliant on being able to check at each point again, is that my receiver? No. Is that my receiver? Yes. And there's the data being dropped off. The disadvantage I see here is, what if the sender, if you've got hundreds of nodes in the network here and the receiver is a long distance away? Let's have a look at that possibility. So if my receiver finds himself here, or herself here, even, you can see even though the receiver is right beside the sender, because everything is getting sent in the one direction here, that we have a situation where there's a long distance to travel all the way around the network to send your message, even though there's a short bit of cabling. So hopefully we can appreciate here how the cabling in the network and the topology in terms of data travel are very different things. You would have thought logically that the data should just go from here to here. Let's make a break in our cable. Boom. Our ring is broken. So we do have that dependency issue on this network where you're trying to send your data around. If any point of the ring is down, then we're in trouble, because we're here trying to get our data and we've knocked out 2 nodes here of the network. So the half our network could be taken down, or a lot of our network can be in this case half the network was taken down by one break in a ring. Same goes if any of the computers themselves break down, you could have issues there along the line as well. Compared to the bus technology, you have less scope for data collision and data redundancy with the data being passed around unidirectionally in the ring. Time to talk star. Okay. So in the star network, this is the one we're probably most familiar with. You got your central hub, you got your outer nodes, and square guys can be our computers, our hub can be the rectangle there, and here's our nodes, our computers outside. They've all got a connection to the central hub. There we go. Okay, more expensive than a bus to set up this, because there's a lot more cabling. You have to buy your hub as well, so a bit more expensive to set up. There's my sender, there's my receiver. So the data goes from the sender to the hub and direct to the receiver. So you've no pass the parcel type mentality that you'd have with the ring or the bus network. It goes straight from A to B, if you like, via the hub. Nice thing here is if you have a break in your line, for example, if I break the line here, my message is still going to get through there, isn't it? You've only taken out one node of that network there by taking that out. You are, however, very dependent on the hub. If the hub goes, the entire network is down. You can't get from any point of the network to any other point of the network. So that's where you have a disadvantage with the star. the mesh. Okay, so let's start again and draw some nodes. So mesh is like, I think of the term web, mesh, you know, things knitted together, okay? So with a mesh network, and where a mesh network is probably most used is where you need backup. Because the whole purpose of mesh really is to make sure that if something goes down, you got a backup line. So you can see this network point here. I'm going to make that the sender. And we're going to make the other network point here the receiver. So first and foremost, it has a direct line to the receiver. As well as the direct line, you can make the trip. The direct line goes through this node to the receiver, from this node to the receiver, and from this node to the receiver. So you can see from any given point on the network, there's a connection in a pure mesh layout. There's a connection from every single point in the network to every single node in the network. So there's very, very high, there's very, very little chance that you're going to lose any data or drop any packets. That's the advantage of a network. The big disadvantage of this type of network, cost. Labor to set this up as well, obviously. Okay, you have to be very thorough. You're only going to use a mesh in the kind of scenario where you can't have downtime. You're working in a hospital and you've got vital data on life supporting machines, or you're working in a fire station where you just can't have that lying down in any circumstances. So you need, if your main line goes down, you need a backup, or even a backup to that backup to kick in. That's where the mesh is appropriate. So this is the theory of how it works, but in actuality, most networks tend to be a blend of the different types that we've shown here. You may have, for example, a network that consists of a star with a few devices hanging off it here, which may link itself along a bus to another star, to another star. So you may have a bus star as a combination. That's the reality of what happens. But the main thing we need to understand is that how the data, or why we need to understand layout, is so that you understand how data passes from one point to another. So if you are trying to diagnose a fault in the network, and you know that somebody who's a sender can't get the data to the receiver, you have to understand where the break could be. Could it be here? Could it be here along the bus? Could it be this point of the bus? Could it be that point just near the receiver there? Could you have one of your hubs down in your star? So you have to think of the various diagnostics that you need to do to identify that. So for example, if I knew this hub was down, or to diagnose that that hub would be down, what you would be doing, perhaps you'd be testing from the sender. You could test this point here, you know it's okay. You could test this point here, you know it's okay. And you could test at this point here, and then you could test at this point here. And when you receive a negative at this point here and a negative at this point here, you're fairly sure that this is where your fault is going to be, because you've got positives all the way along from the sender to that point there. So understanding the logical layout of a network helps you diagnose faults really well. So that's why it's important to understand a little bit about network topologies, or in plain English, network layouts. In this tutorial we talked about topology, which is a fancy word for the layout of a network, place the emphasis on the fact that we're not talking about the physical layout. We're trying to understand more how the data gets from one point to another on the network, which is known as the logical layout. We went through different types of classic layouts, such as the bus, and identified that as a cheap way of setting up a network. However, with a break in the central line, it could easily break down the entire network, or a lot of a network. We also refer to the terminators of a bus, eliminating the possibility of too much network noise or traffic on that network. Then we went on to talk about the ring, which passes data from one point to another in a circular fashion around the network. Again, cheaper to set up with less cabling. However, if there's a break at any point in the ring, it can bring down a lot of the network, or the entirety of the network. A star network was then described, where data passes from one node through a hub to another, while a point or a line on the network can break down and not cause too much disarray or any disarray to the rest of the network. If the central hub is gone, then the entire network can go down quite easily. For a star, a mesh network is all very costly way of networking, because you're cabling from each point or each node of the network to the other point directly. The big advantage, however, is that you nearly always have a backup. So if any line goes down, there's a backup through another point on the network that you can travel on. Finally, I showed a typical real-life network, which is usually a combination of the theoretical networks that were described. But it's good to understand the theory, because if you have a break in the network, by understanding how the data has passed from one point to another, you can more easily identify where that break has occurred.